Alright, we're picking up where we left off on page 122. From the last video, we graphed the top of page 122 based on the problem on page 121, and then that's where we stopped. So at the bottom of this page, we won't take up so much space to do the next one, so I'm not going to write everything out. But for example, we are going to graph y equals x plus 4 divided by x minus 4. X plus 4 divided by x minus 4. And if you look back at the directions that we had previously, our first step, and remember I told you this yesterday, that the steps that it gives you, you don't have to go in order of the steps, but you have to find all of those things. Okay, so I'm just going to go in order of the steps. So on page 119, the first step said, find the x-intercepts of the function, substitute a 0 in for y to solve for x. So the first thing I'm going to do is I'm going to find the x-intercept. And I'm going to draw my graph over here to the right. I don't need a big graph, so make sure you leave yourself a little space. So to find the x-intercept, I'm going to take my equation. Where I see a y, I'll plug in a 0. And I will solve for x. Now, since I have a rational equation, we can either find the cross product or we can clear the fractions. I just like to clear the fractions. So I will multiply every expression or every term by the least common denominator, which is what? X minus 4. So on the left side, x minus 4 times 0 is 0 equals. On the right side, x minus 4 and x minus 4 cancels. And I'm left with x plus 4. And then I can just solve for x, right? Subtract 4 from both sides. And my x-intercept is negative 4. I'm going to go ahead and sketch my little graph in, and I'll just plot these points and intercepts as we go. So this graph's only going to cross the x-axis once. In the graph that we did above on the same page, it crossed the x-axis 2 times. This one's just going to cross it 1 time. Okay? Now step 2 on page 119 said find the y-intercepts. Substitute a 0 in for x, and then we'll solve for y. So that's going to be my next step. I will find my y-intercept. So I'll have y equals, wherever I see an x, I'll plug in a 0. So 0 plus 4 divided by 0 minus 4. So that is 0 plus 4 is positive 4, 0 minus 4 is negative 4. Y equals negative 1. So when x is 0, y is negative 1. That's my y-intercept. Coolio? Bless you. Step 3, find any vertical asymptotes. Graphs can have an unlimited number of vertical asymptotes. Doesn't mean we're going to have a vertical asymptote, but if you do, you can have, it's not restricted on how many vertical asymptotes you can have. Okay? Remember, asymptotes are a line that a graph approaches but does not cross. So vertical line straight up and down. So to find vertical asymptotes, make sure the numerator and denominator are completely factored, which our numerator and denominator are completely factored. It gave it to us that way. Cancel any common factors. Can we cancel any common factors? No. If no factors can be canceled, which is us, then the vertical asymptote is the same as the restriction. All right? So our vertical asymptote, the restriction, I would say x cannot equal 4, right? But for the asymptote in an equation, we don't put the not equal sign. So our vertical asymptote is at x equals 4. So there is no point in this graph that can have an x value of 4. So we will draw in that positive 4 dash line, and that's my vertical asymptote. And obviously I only have one, there's only one factor in the denominator. You never look at the numerator for your vertical asymptote, just the denominator. Okay? Everybody cool with that? See how I color coordinated and everything so you can see what goes to what? Awesome. Step 4, determine if you have a horizontal asymptote. The graph of a rational function can have no more than one horizontal asymptote. So you may not have any horizontal asymptotes, but you can have one horizontal asymptote, but no more than that. Okay? And for the horizontal asymptote, we look at the degrees of the numerator and the degrees of the denominator. How many degrees does my numerator have? How many does the denominator have? 1. So if we look back at our notes on page 120, believe it's right here. If the degree of the numerator is equal to the degree of the denominator, which is our case, then the graph has a horizontal asymptote at y equals a divided by b, where a is the numerator's leading coefficient and b is the denominator's leading coefficient. So it's, what's the leading coefficient?
1.
Divided by? 1. So a is 1, b is 1, right? So what is the equation of our horizontal asymptote? 1. Whoops, I should have put a y equals. So y equals 1. That's a vertical. I'm sorry, not vertical. Horizontal asymptote goes through positive 1. Trying to make this as pretty as I can. Need a ruler. So we have separated our graph into how many sections?
4.
Regions. 4, right? We got one here, one here, one here, and one here. And this is a function. So could part of my graph be in this region and in this region?
Yes. No.
Nope, because it wouldn't pass the vertical line test, right? Could it be in this region and also in this region? Yeah, this region and this region.
But if the X and Y intercepts are in the other area, how would it go to the other side?
Well, okay, so good question. So in this particular graph, the only points that we know are in this one region here. Okay, so you're saying it could not be in this region.
Yeah.
Okay, I get what you're saying, because the points are down here.
Yeah, I thought you were saying in relation to the
You're right. I wasn't even thinking about the points. I was just thinking about, pretend those weren't there, all right?
Okay.
Could it be in this region, in this region? Yeah. Could it be in this region and in this region? No, because that wouldn't pass the vertical line test, right? So we know part of our graph is in this region. We know that because that's where the only 2 points that we have are. But first of all, we forgot to see if there was an oblique asymptote. So let me just do that real quick, which was step 5. Determine if you have an oblique, that's also called a slant asymptote. This only occurs in rational functions when the degree of the numerator is 1 greater than the degree of the denominator. which is not because they're equal, right? Okay, and you're not going to have a horizontal asymptote and a slant asymptote. It's not going to happen. Okay, so there is no slant asymptote. So I know I can go ahead and graph the part of the fraction that I know. I know it's going to hug the asymptotes. And I don't need to really find any more points on this side, just kind of give it a general sketch. I know I can't have any graph up here because that would not pass the vertical line test. But just because I haven't found any points over here, this region, it's not, the x-axis isn't in it and the y-axis isn't in it. So I wouldn't have found those points. That does not mean that part of my graph, I won't have another part of the graph over there. You know what I mean? So I'm going to have to pick a test point to see, and I may not have another point over there, but I need to pick a test point to find out if I'm going to have another point over there. So I don't want to pick any x values from this asymptote to the left because I already have stuff for all those x's. So I'll probably pick when x equals 5, plug it in, get an ordered pair. Okay? So my test point is going to have an x value of 5. Comma 9. So that's you can find more points if you want, but that tells us what region that we're going to be in. Okay, when x is 5, y is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of hard to tell without graph paper, but I think about right there. You want to plug in a 6, cool. You want to plug in a 7, cool. But it's not like it's going to come and do some loops or something like that. It can't run into the asymptotes. It's just going to follow along the asymptotes. But again, feel free to plug in as many x's as you want. So knowing that we have that graph up there, automatically you can't have one down here, otherwise it would not pass the vertical line test. Now these two graphs, they're the same graph. Is there any place with where I drew it here and where I drew it here that it's going to cross your vertical line more than once? No, because the asymptote kind of stopped it from doing that, right? How awesome is that? Pretty awesome. If you have your own graph paper, I would like for you to get it out. Please, on the next problem, a lot of the asymptotes and like intercepts are really close to each other, so I want them to be on a piece of graph paper. So I'm going to pause this video right now. Let us all get our graph paper out. If you don't have any, I'll let you borrow some, but if you do have some, please use your own. And we're going to glue the whole piece of graph paper to page 123. And I'm going to pause, and hopefully I don't stop recording the whole thing. Alright, so page 123, we are going to graph f of x equals, which we know f of x is the same thing as y equals, right? X squared minus x, quantity divided by x plus 1. Now, in the last problem that we did, everything was already factored. The numerator and the denominator were factored, so I didn't mention anything about factoring. In this equation, or this function, we can do some factoring in the numerator, so I like to just go ahead and do that. F of x equals, how am I going to factor x squared minus x? GCF of what? X. So factor out an x. What's left inside parentheses? X minus 1. Can that be factored any further? And no. Can I factor my denominator?
No.
No. X plus 1. Alright, and I'm going to find all my stuff. I'm going to go ahead and draw my graph in. And I'm going to draw a pretty decent sized graph. Now I'm going to make it really pretty and stuff. Put it over here on the side. It's probably a bigger graph than we need, but that's okay because we're using this whole paper for this one problem. On my desk. Okay, so the first thing I'm going to do according to the steps, and the same thing we did in the last example when you're graphing rational functions, is I'm going to find my x-intercepts, if there are any. So remember, if you want to find where the graph's going to cross the x-axis, every ordered pair on the x-axis has a y value of 0. That's why if you want to find the x-intercept, you plug a 0 in for y and solve for x. So instead of f of x, it's the same thing as y, right? So I'm going to set that equal, that's going to be 0, equals x squared minus x over x plus 1. And I could have done the factored form of that x times x minus 1 instead of x squared minus x. Really doesn't matter on this because these are getting ready to cancel, and so either way it doesn't matter. Okay, I'm going to clear my fraction, so I'm going to multiply both sides by the least common denominator, which is what? X plus 1, which will cancel that denominator out, and x plus 1, which will turn the left side of my equation into a 0. So I have 0 equals x squared minus x, which we already know could be factored to x times x minus 1. So probably would have been easier if we would have just used the factored form, but whatevs. We can fact. We already know the factors, so. And if I'm trying to solve for x using factoring, once I know the factors, how do I solve for x? Set each factor equal to 0, right? And then just solve for x. So is x a factor?
Yes.
Yeah. Set it equal to 0. X minus 1 is a factor. Set it equal to 0. Yes, it will be positive 1 because we add 1 to both sides. X equals 1 and x equals 0. So I will plot both of those points. My x-intercepts are 1 and 0. Everybody cool with that? Alright. What do we do next? On the y-intercepts.
It can only be one, right? Oh,
You're thinking about horizontal.
yeah.
There can only be one horizontal asymptote. But no, for y-intercepts, you can have more than one. So for y-intercepts, any point on the y-axis has an x value of 0. So now, if we want to find where the graph's going to cross the y-axis, we'll plug in a 0 for x and solve for y, right? So we'll have y equals, you can either do this in the original problem or the factored form. I'll do factored form this time. Y equals 0 times 0 minus 1 divided by 0 plus 1. So 0 times -1 divided by 1,
That's 0 over 1.
which is what? 0. Can my graph cross the y-axis at 0?
Yeah.
Yeah. And as a matter of fact, we already have a point there, so that's okay. It's just my x-intercept and y-intercept are both 0. No big deal. Next on my list, find any vertical asymptotes. You can have an unlimited number of vertical asymptotes. You may not have any, but you can have multiple, okay? Find any vertical asymptotes. So these are the ones for the asymptotes. You may want to keep referring back to your notes until you have it in your head what's what. So for vertical asymptotes, make sure the numerator and denominator are completely factored, which we did. Let me go ahead and write that down, the factored form. I wrote y equals, I meant to write f of x equals. It's not really a big deal. Make sure they're factored. Done. Cancel any common factors. Can we cancel any common factors?
No.
No. If no factors can be canceled, then the vertical asymptote is the same as the restriction. This is referred to as non-removable discontinuity.
So -1.
So, yes, the equation of my vertical asymptote is -1 because that's my restriction, right? So my vertical asymptote is x equals -1. And again, because sometimes you're going to be asked, name your removable and non-removable points of discontinuity. Well, since we can't remove a factor, nothing can cancel, we would say this has a non-removable discontinuity at -1. Okay, in case they ask you that. So I'm going to say this function has a non-removable discontinuity at x equals -1. And that is the equation of my vertical asymptote. Verticals up and down, so I'm also going to draw that vertical line at x equals -1. Cool beans? Horizontal asymptotes. Find any horizontal asymptotes. There aren't any? Well, let me investigate. Find any horizontal asymptotes. So if we look back on page 120, determine if you have a horizontal asymptote. The graph of a rational function can have no more than one horizontal asymptote. If the numerator is less than the denominator, is that our case? the degree, right?
Yeah.
Our numerator degree is
Bigger than our
2, denominator is 1, okay? So we don't have to worry about that one. If the degree of the numerator is greater than the denominator, is that us?
Yeah.
Okay. Then the graph has no horizontal asymptote. Sweet. If this happens, check to see if there is an oblique asymptote. Okay, so we know there's no horizontal asymptote.
Where's the blue one?
There is not a, I'm going to call it HA, horizontal asymptote. Sorry, that's messy. HA. There's not a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. Since we don't have a horizontal asymptote, we're going to check for a slant or oblique asymptote. An oblique or slant is a vertical asymptote's a line, a horizontal asymptote's a line, right? Well, an oblique asymptote, it's also a line, it's just not vertical or horizontal. Okay? Like it has a y-intercept and a slope and all that stuff. So, according to the directions that we wrote, or that we had written on page 120, say, determine if you have an oblique or slant asymptote. This occurs in rational functions when the degree of the numerator is 1, it can only be 1 degree greater than the degree of the denominator. Our numerator is 2 degrees, our denominator is 1 degree. Is this going to have a slant asymptote?
Yeah.
Yes, it is. Okay, now how do we figure it out? If so, use long division to find the quotient. That's what's on top of the little division house. This is the equation of the oblique asymptote. Ignore any possible remainder. So if you do this and you get a remainder, it has nothing to do with the asymptote. We just need to figure out what goes on top, okay?
X plus 1 divided by, or x squared subtract 1 divided by x plus 1? Or is it?
Well, we're going to take our original problem, x squared minus x, and divide that by x plus 1, okay? This will be a good little review for division of long division of polynomials. Yay. X squared minus x, and I'm missing that constant, so I'll just put a plus 0 on the end. I'll zoom that in a little small. So hopefully y'all remember how to do this. We just tested out over it not too long ago. X times what is x squared?
X.
X. That's linear, right? So I put it above the linear term. Then I multiply. X times x is
Square.
x squared. X times positive 1.
The x.
What's my sign?
Minus x.
Uh,
But if it's a positive,
Plus.
you have to switch it to negative.
we're not there yet, though. So now we draw a line and change the signs. So we're drawing a line. Positive x squared becomes negative x squared, and positive x becomes negative x. Right on? Crouton. Alright, what is x squared minus x squared?
0.
And remember, if those first two terms don't cancel, something's wrong. Okay? Now we have be careful before you answer. Negative x minus x. Negative 2x. I'm so proud. Now I'm going to bring down the plus 0. Were y'all expecting me to say drop it like it's hot? Oh, good. I didn't feel whole not saying it. Okay, x times what is negative 2x?
-2.
Negative 2. Negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. Now, really, because of what we're looking for, at this point of the game, when we draw a line and change the sign and we get a remainder of 2, once we get to our remainder, we don't care what the remainder is. If our goal was just dividing polynomials, yeah, the remainder is important. But when we're looking for the oblique asymptote, we only care about what we have up here, whatever the quotient is. That is the equation of our asymptote, okay? So, you know, an equation has an equal sign in it. In the equation of a line, you usually see like a y equals. So this is the same thing as y equals x minus 2. And y'all have to remember how to graph lines now. Remember, this is slope-intercept form. We have a slope, we have a y-intercept. Which part of that is my y-intercept? Boom. And what's my slope? Positive 1. What do I graph first? My y-intercept. Negative 2 on the y-axis. Negative 2. My slope is a positive 1. Rise a 1, run a 1. So it's positive. That means the right side of the graph has to, or the right side of my line has to point up. So if I have a rise of 1, if I go up 1, do I go left 1 or right 1 to make a positive slope? Right 1. Does that mean I can't go down? No. It means if I go down 1, I go left 1. How many points do you need to make a line? Little geometry review. 2. Why am I drawing so many? Because I like it to be precise. I don't like just willy-nilly. Especially because that oblique asymptote was so close to those intercepts. And if this is why I wanted to use graph paper, because I wanted it to be, at first when I did this in my own notes, I didn't use graph paper, I just hand drew it. And it was hard for me to tell by my hand drawing what region these points were on. You know what I mean? Because I had my line, it was too steep. And so that's why I decided that we should put this on graph paper. So how many regions do I have? My asymptote separated this into how many regions? 4. I've got this here, which we know we're going to have part of the graph in there because those 2 points, right? We've got this region here. We've got this region here. We've got this region here. But I know that if I'm going to have a part of my, and it's ugly, I didn't want it to be ugly. If I'm going to have part of my graph in this region, could I have part of the graph in the region below it? No. But I could have something in one of these regions to the left, right? I don't want to just guess and assume that it's diagonally across. It may be, it may not be. So how am I going to figure it out? Because I don't have any other points to look at. What should I do? Pick a test point, right? So I don't want to pick any x value from this asymptote to the right because I have points for that. So maybe negative 2 when x is negative 2. And I'm running out of space. So I know I'm not going to draw anything down here. So my test point is going to be x equals negative 2. You can plug that into the standard form that it was given to you or the factored form. I like the factored form. So I'm going to find f of negative 2. So negative 2 times negative 2 minus 1 all divided by negative 2 plus 1. Careful of your order of operations. So it's negative 2 times negative 2 minus 1 is negative 3. Over negative 2 plus 1 is negative 1. So negative 2 times negative 3 is positive 6. Divided by negative 1 is negative 6. So I have negative 2 comma negative 6. Let me plot that. When x is negative 2, y is negative 6. 1, 2, 3, 4, 5, 6. So that point is going to be in that region. So just do your best to remember it's going to hug. And it may go up higher. I don't know, but we're just sketching it, right? So is there any need to find any other test points? No, because I know I cannot have a graph up here. It wouldn't be a function if I did. Only other thing I want to say about this graph that you may be asked are or is or are. The one thing I want to say is, if it asked you what your domain was, does anybody know what your answer would be? What does domain mean, first of all?
Your x.
All possible x values, right? So what's our domain? Look at the graph. Can x be all real numbers?
Yeah.
Negative 1. That's what our whatchamacallit tells us.
Vertical asymptote.
A vertical asymptote, which we got from the,
Denominator.
what do we call that? When I ask you what x is,
Denominator.
what x cannot equal?
Restriction.
Restriction. That's telling you x cannot equal negative 1. That's why we do an asymptote there. So hold on, write this down. Don't, just one thing that's important. Our domain, any x except for negative 1. The way we write that is, you can either say all real numbers except negative 1, or remember the fancy all real number sign, except negative 1. Next class, I want to show you one more graphing problem. I want to show you one that has a hole in it. We just didn't have enough time today. And then we'll be finished with rational expressions and equations. Anybody have a question, comment, or concern? Look it up. It's good? Okay.
Want your rollers back with you?
Enjoy your video. Hope you watch again this weekend.
Because I lose these things anyways. Thanks. I'll keep rolling.